Good morning, everyone. In today's class, I'm going to take you to continuity chapter. This is there for CBSE and for ISE 12 standard as the fifth chapter. Now, what is continuity? Well, basically, continuity starts, the limits part of it starts at 11th grade. So you have to be thorough with some of the standard limits to be very comfortable with this chapter. So let me first explain what is continuity is. A real function should be considered continuous at a point if the graph of the function has no break at a point. So imagine there is a graph and you take a particular value of x and you plot it, like you find the x and the corresponding y value for that. There is a graph already for a function and you've been given an x value, all right? And now you substitute that x value in the function to get the y value. And then you plot that in the graph. Now what you find is that the graph is not in continuous with the point, which means imagine the graph is like this or something, but the point you're getting is somewhere here or somewhere here where you cannot you have to take your hand out in order to connect it to the graph. So a graph of breaks at a particular point, then it is said to be discontinuous. Or when you cannot draw a function without taking pen from the paper, if you cannot draw without taking a pen from a paper, then it is said to be discontinuous. Okay, so when you can draw it when you draw it continuously, but if you can draw it continuously, then it is said to be a continuous function. If the graph of the function can be drawn without lifting the pen from the paper, then it is said to be a continuous function. Understood? Now, so in simple terms, if the graph breaks at a particular value of x, then it is said to be discontinuous. And if it doesn't break, it goes in a continuous process, then it is said to be a continuous function. Now, technically, this is a definition. But when you do it in the method wise, there will be two methods to it. Method 1 is limit x tends to a, f of x is equal to f of a, where a belongs to the domain of the function. Now, when limit x tends to a, f of x is equal to f of a, then the function is said to be continuous at a. 2. Limit x tends to a minus f of x is equal to limit x tends to a plus f of x is equal to f of a. In short, left hand limit equals to right hand limit equals to f of a for a value of a that belongs to the domain of the function. Now, if left hand limit is equal to a right hand limit, then it is said to be continuous. Left hand limit equals to right hand limit is equal to f of a, then it is said to be continuous at a. If limit x tends to a is equal to f of a, then it is also said to be continuous. Now, why there should be two ways of doing this? Well, in questions where the left hand, right hand doesn't make any difference, then we'll be doing only the method 1. Which means in the question they said, like, when x is less than a, there is a function. When x is greater than a, there is some other function. Then we will be opting the method 2. So lesser than a, greater than a, we simply have one function. Then there is no need to do left hand limit or the right hand limit. Simply do limit x tends to a, f of x is equal to f of a. Right? Now let's see questions from the NCERT textbook first. But before that, I would list out some of the standard limits. It is very important that you're aware of the result of these standard limits so that we can apply that in any sums anywhere. Well, these are some of the standard limits that you must have used in your 11th grade in the chapter limits, right? And we might be using this in this chapter also. So limit extends to a x to the power of n minus a to the power of n by x minus a is n a power n minus 1. Limit extends to 0, sin x by x is 1. Limit extends to 0, tan x by x is equals 1. Limit extends to 0, sin inverse x by x is 1. Limit extends to 0, tan inverse x by x is 1. Limit extends to 0, e power x minus 1 by x is also 1. Limit extends to 0, a power x minus 1 by x is equal to log a base e, and limit extends to 0, log of 1 plus x by x is also 1. Now, when you apply this standard limits into a sum, the most widely used one is sin x by x and tan x by x, okay? Make sure x is tending to 0. X must be tending to 0. Simply getting sin x by x is not enough to put 1. It should be x tending to 0. So, all the neighboring points at 0, that means below 0 and above 0 are continuous when the function is sin x by x. That's what it means. Alright, now let's start the sums from the textbook. Well, as you can see, this is exercise 2.5.1 from the chapter Continuity and Differentiability from NCERT textbook. So this is the base. But when it comes to the different models, a higher level question, we need to use different other books. So this is the basic now. Okay. Prove that the function f of x is equal to 5x minus 3 is continued at 0, minus 3 and 5 separately. Now here what to do? Here I'm going to do method 1 where there is no use of doing left hand limit or right hand limit because it is going to deliver the same answer. Hence, I'm going to do only the method 1. So which means I'm going to do limit extends to 0 f of x and see whether that's equal to f of 0. Alright? Okay. So the question is, the limit extends to 0 because they want us to try for 0 first. So we're doing it for 0. F of x is 5x minus 3. So when you apply the limit, 5 into 0 is 0. 0 minus 3 is minus 3. Now f of 0, which is also 5 into 0 minus 3, which is also minus 3. So limit extends to 0, f of x is equal to f of 0. Hence it is continuous at 0. We do the same for the next two numbers. I think they've asked for minus 3 and 5. We do the same thing, just the same way. At x equal to minus 3, limit x tends to minus 3 will be 5 times minus 3 minus 3. So minus 15 minus 3, that's minus 18. And f of minus 3 will be the same thing, 5 into minus 3 minus 18. So limit x tends to minus 3, f of x is equal to f of minus 3. So this is how we do the next case also. Okay, I will be a bit choosy here. Maybe the time doesn't permit me to do all the sums, so I'm going to pick only a value. So that is how we do the first question. Coming to the second question, that is almost same like the first one because it is asked to check for x equal to 3. So limit extends to 3 on 2x square minus 1 should be equal to f of 3, and it would be obviously, isn't it? So 2 is over. Now coming to the third question. Examine the following functions for its continuity. When in 1 and 2 question, x is given. They want us to check for a particular value of x. So in the first one, as you can see, it was 0, then it is minus 3, then 5 and so on. But here nothing like that is given. So how do we do this? Well, when you take these kind of question, define the domain of the question first. F of x is x minus 3. The domain is all real number here, isn't it? The domain of this is all real number. But when you see this one, the domain will be all real number except 5, right? Except 5. Whereas here also all real number except minus 5. and here it's all real number. Now first we define what is the domain of the function is. Then we take an arbitrary value from the domain and and then prove it's continuous for that. So I like to do it for the B1 and show you. F of x is equal to 1 by x minus 5. So domain of f is what? All real number except 5. Hope you all know the reason why we omit 5, right? Now, let a be any arbitrary element that belongs to the domain of the function. Let a be any arbitrary element that belongs to the domain of the function. Limit x tends to a, f of x would be limit x tends to a, f of which is 1 by a minus 5. Alright. And f of a will also be 1 by a minus 5. Can you see this? Yes. So limit x tends to a, f of x is equal to f of a. Hence it is continuous for a. So this is how we do the questions where the x value is not given. So we take an arbitrary element and we'd go for that. Okay. Now, so that is how we do the third question as well as the fourth question. Now, coming to the fifth question. Is the function f of x defined as x when it's less than equal to 1 and 5 when it is greater than 1? So here a critical point is given in the question. So the critical point is 1. If you go below 1 or 1, if you take 1 or below 1, the function is x. And when you take above 1, it is 5. So when a question is given like this and they ask us to do for 1, for that very critical point for which it has been defined and they've asked to do the continuity for that number, then do method 2. That means do left hand limit, right hand limit and f of a. But when it comes to 0 and 2, I don't want to waste my time by doing the method 2. No LHL RHL will do because it is going to deliver the same answer. Left and right, the neighboring point will give you the same values. Therefore, I'm going to follow only the method 1 where it is going to be limit x tends to 0 f of x is equal to f of 0. Alright, so that is so I'll just show you for 1 and 2 here. Alright, I think you will understand the rest on the way. Okay, let me clear this. F of x is equals to x and 5. X when it's less than equal to 1 and it's 5. Let me just show for 1 first. So I'm going to do for 1. So limit x tends to 1 minus. 1 minus means any value below 1. Alright. The function is x there. And we substitute 1 only in the place of x, though we write 1 minus. We are not going to take any values below 1 because we know the points will be close enough. So we take only that number, x equal to 1. So 1 is the answer. And now limit x tends to 1 plus. 1 plus means above 1 and above 1 the function is 5. So answer is 5. Right? So what do we observe from this? Left hand limit is not equal to right hand limit. Hence, it is discontinuous at 1. It is discontinuous at x equal to 1. Now, they want us to do it for 2 also, I think. Isn't it? Let me check once again. Yeah, they want us to do it for 0 and 2. I'm doing it for 2. Now, 2 is a number that comes after 1, isn't it? So this is where x greater than 1 where the 2 lies. So the function at that point is 5, right? So at 2, I'm going to do only the method 1. So no LHL RHL here. Limit x tends to 1. Limit x tends to 2 on 5. Going to be 5. And f of 2 will also be 5. Therefore, limit x tends to 2 is equal to f of 2 on f of x is equal to 2. Hence, it is continuous at x equal to 2. Understood? So now let's start from the sixth question. As I said in the beginning, I have to be a little selective here. So I'm going to do the seventh question, and the ninth question. So seventh question is f of x is equal to mod x plus 3 when x is less than equals to minus 3, minus 2x when minus 3 is less than x less than 3, and 6x plus 2 when x is greater than equal to 3. Right? Alright. Now as you can see here, the question is defined for minus 2, minus 3 and for 3. The question is defined for minus 3 and 3. So at x equal to minus 3, limit x tends to minus 3 minus will be, so okay, let me just split the mod function and write it as minus x plus 3 when x is less than equals to minus 3, and minus 2x when it is between minus 3 and 3, and 6x plus 2 when x is greater than equal to 3. Isn't it? That is how we define mod function, isn't it? So if you want to understand this one, let me take it to you. Mod function, just a mod x means critical point is 0. So below 0, the function has to be minus x, and above and greater than, above and 0, above and equal to 0, it's going to be x, right? And x equal to minus 3 means a number below 0, right? So the function have to be minus x here. So that is why it is minus x plus 3. All right. Now, when you do minus 3 minus, the function is minus x plus 3. So it is minus of minus 3 plus 3, so 6. So LHL is over. Limit x tends to minus 3 plus. Above minus 3, the function is minus 2x. So that means I get minus 2 into minus 3, which is also 6. And f of minus 3 will be minus of minus 3 plus 3, which is also 6. So left hand limit equals to right hand limit equals to f of minus 3. Hence it is continuous at minus 3. Now let's do it for 3. The limit extends to 3 minus will be minus 2x. So it will be minus 6. Limit extends to minus 3 plus would be 6x plus 2, right? Limit extends to 3 plus, not minus 3, 3 plus will be 6 plus 2. So 6 into 3, 18 plus 2. Come to a conclusion that it is discontinuous. It is discontinuous at x equal to 3. Clear? Now moving to the next question. This is question number 1. Now question number 7 is over. Now question number 9. F of x is x by mod x. So how does this will become? Because as I explained, the way we split mod x, since x is less than 0, mod x becomes minus x. So the function will change to a form of x by minus x when x is less than 0 and minus 1 when x is greater than 0. Right? When x is below 0 or less than 0, mod x will be minus x. Hence, this will further change to minus 1 when x is less than 0 and minus 1 when x is greater than equal to 0. Hence, from seeing this, we can straight away say that it is continuous at 0, because left hand limit is also minus 1, right hand limit is also minus 1, and at 0 the value is minus 1. So this is continuous at 0, so no point of discontinuous for this one. So that is how we do. So wherever there is an inequality sign like less than and greater than, we do the method 2. Now when you see the question number 8, there is no less than or equal to, right? So here we can use method 1, but it's mod x by x. So I like to do the 8th one also. 8th one, it says f of x is equals to mod x by x when x is not equal to 0, and I think 0 when x equal to 0. Now mod x becomes minus x by x when x is below 0, and 0 when x is equal to 0 as instructed in the question, and x by x when x is greater than 0. So this will further change to a form of f of x equals minus 1 when x is less than 0, 0 when x is equal to 0, and 1 when x is greater than 0. Now, if I have asked to check the continuity at 0 for any value, we do it for 0 here. Limit x tends to 0 minus will be on the function minus 1. So answer is going to be minus 1. Limit x tends to 0 plus will be on 1. So answer is 1. Therefore, left hand limit is not equal to right hand limit here. Hence, the point of discontinuity is 0. So that is how we do the questions from this page. Alright. Now, discuss the continuity of the following function where f is defined as so and so. Now, they haven't told us for what value we are supposed to find, but they want us to discuss for all points. So let us first discuss with the point that has been given in the question. So here they said between 0 and 1 your function is 3. Between 0 and 1 including 0 and 1. Between 1 and 3, that means all numbers between 1 and 3, not 1 or 3. It's 4. And for 3 and 10 it is 5. Okay. When I do it for 1, less than 1 it is 3 and above 1 it is 4, right? Therefore, definitely it is discontinuous at 1, right? And similarly, when you do it for 3, less than 3 it's 4 and greater than 3 it's 5. Therefore, it's discontinuous at 3. So, when you do this sum, you have to do it for 0, you have to do it for 1, you have to do it for 3, and you have to do it for 10. When you do for 0 and 10, we do the method 1. We do the method 1, wherein we don't need to do LHL or RHL. But when you do it for 1 or 3, you have to do LHL or RHL. LHL, RHL and F of A. That means we have to do method 2 here. So for 1 and 3, it's method 2. For 0 and 10, it is method 1. And coming to 15th question, for 1 below 0 it is 2x, above 0 it is 0, below 0 it's 2x, above 0 it is 0. So again we have to do method 2 here when x equal to 0. And for 1 also we have to do method 2. Understood? Yeah, that is how we do 14, 15, 16. Now coming to the 17th question. Find the relationship between a and b so that the function is continuous at 3. So they said it is continuous. If they said it is continuous, left hand limit is equal to right hand limit, isn't it? So limit x tends to 3 minus on ax plus b, ax plus 1 is equal to limit x tends to 3 plus on bx plus 3. So you get 3a plus 1 is equal to 3b plus 3. So I get 3a minus 3b equals to 2. So I can say that 3a equals to 2 plus 3b. So this is the relationship between a and b. Clear? Now coming to question number 18. For what value of lambda the function will be continuous at 0, and what about continuity at 1? When you do it for 0, limit x tends to 0 minus, limit x tends to 0 minus will be on lambda times x square minus 2x. Limit x tends to 0 minus will be lambda times x square minus 2x. Obviously, when you apply 0 in the place of x, the answer would be 0. Right? There is no lambda at all. So limit x tends to 0 plus, and when it is above 0, it is 4x plus 1. 4x plus 1. So that the answer is 1. So where is lambda here? How do I equate it when there is no lambda? The question was to for what value of lambda it can be discontinuous. Well, there is no values to lambda for this question. Lambda has no real values, right? Values for lambda. But then they also want us to check for 1. When you check for 1, you don't need to do method 2. We just have to do only the method 1. So when x equal to 1, 1 lies here above 0. So I'm going to do at limit x tends to 1 on 4x plus 1. So that would be 5. And f of 1 will be 5 again because it's going to be on 4x plus 1 only. So it's continuous, but the problem is again lambda is not coming up. So lambda can take any value here, it doesn't hinder at all. So lambda can take any value when it comes to 1, when you check for 1, and when it comes to 0, no values of lambda. Explain till 18th question. I'm not going to do the 19th in today's video. Will be in the next video. I'll pull up some more questions based on the greatest integer function and help you to understand the 19 in a better way. Now, coming to the 20th question, the function is x square minus sine x plus 5 and it is continuous at 5. Check whether it's continuous at 5. Which method you will do? Method 1 or method 2? Method 1, isn't it? Because method 2 we will do only when there is an inequality less than or greater than pi, then we do it. So here it is enough if you do method 1, right? Coming to 21st question, discuss the continuity of the following function. Okay, now one more important point. When a function is continuous, when two functions are continuous, the sum of the function is continuous, the difference is continuous, the product is continuous, the quotient, the division is also continuous. Okay, the composition is also continuous. So when two functions are continuous, the sum, difference, product, division, and then the composition, everything is continuous. So since no x value is clearly defined here, we do it for the domain value of sine and cos. Okay, and both the domain values are real numbers here. Hence, sin x is continuous, cos x is continuous at all real numbers. Therefore, sin x plus cos x is continuous. Sin x is continuous, cos x is continuous, so sin minus cos is also continuous. Sin x is continuous, cos x is continuous, so sin x into cos x is also continuous. Clear? So when two functions are continuous, the sum, difference, product and division form, everything is continuous. Coming to 22nd question, discuss the continuity of the following. Now here also this is similar to the first and second type of questions, except these are trigonometry functions. That's the only difference. So what do we do here? We define the domain. We simply define the domain of the function and then we take an arbitrary value in the domain and then we do it for that particular value. So as I said in the beginning, these are very basic questions, make you to understand the concept better. Okay? Okay. Now, coming to question number 23 now. Find all the point of discontinuity of the function. Well, below 0, above 0, so we have to do left hand limit and right hand limit here, right? Let me look at the question once again. Yeah. Limit x tends to 0 minus, it is sin x by x. And as per the standard limit, if limit x tends to 0, sin x by x is what? 1. So limit x tends to 0 plus on x plus 1, I guess, yes, on x plus 1, which will also be 1. So limit x tends to 0 minus is equal to limit x tends to 0 plus. So that means LHL equals to RHL. So it's continuous at 0. 24. Here it is x not equal to 0. F of x is x square into sine 1 by x. And 0 when x equal to 0. Now here, should we do method 1 or method 2? Method 1, where there is only one function below 0 and above 0 also. Since it's not a mod function, there is no need to split. So we're going to do only the method 1 here. Limit x tends to 0, x square into sine 1 by x. Now when you apply 0, x square will give you 0 and sine 1 by x will have a value that oscillates between minus 1 to 1. Right? Sine 1 by x will have any value that oscillates between minus 1 to 1. Hence, the resulting answer will be 0. Isn't it? Sine 1 to 1, it oscillates between minus 1, it will be 0. And f of 0, it is given as 0. So, limit x tends to 0, f of x is equal to f of 0. So, it's continuous at 0. 25. 25 also similar to 24, where we do the method 1. So it is limit x tends to 0 on sin x minus cos x. Sin 0 is 0, cos 0 is 1. So answer would be minus 1. And f of 0 is minus 1. So limit at 0 is equal to f of 0. So it is continuous at minus 1. Now, from question number 26 to 30. Question number 26 to 30. 27, 28, 29 are fairly very simple sum. Okay, but 26 is going to be an important question. This one now, and I said this one is an important one. What makes this unique? Well, the type of the question, let's do for x tends to pi by 2. Method 2 again, method 1 again. K cos x by pi minus 2x. When you apply the limit, you get k times cos pi by 2, and what is cos pi by 2? 0. Denominator is pi minus 2 times pi by 2, which is pi minus pi, 0. So this is in the 0 by 0 form. So I have to simplify this. Now, to what extent or what can I do with this? Because numerator is the cos function, denominator is a pi minus 2x, like something with algebra. So what do I do with this? Well, we follow the H method here. Limit x tending to pi by 2. So that means x minus pi by 2 will tend to 0. And I'm going to consider h as x minus pi by 2. So if h is x minus pi by 2, then h plus pi by 2 is the x value. Right? Now the question will transform as limit h tending to 0. When x tending to pi by 2, it becomes h tending to 0. K cos times pi by 2 plus h divided by pi minus 2 times pi by 2 plus h. So limit h tending to 0, cos 90 plus theta. Cos 90 plus theta falls in the second quadrant, where cos is negative and 90 means it will change its course. Complementary theorem will apply. So this will be minus sin h divided by pi minus 2h. So we get k being a constant is out of the limit. 2 is also a constant out of the limit. The minus get cancelled. Limit h tends to 0, sin h by h. And this is 1. So the answer is k by 2 over here. Now at pi by 2, that is f of pi by 2 is given as 3. It is said in the question that it is continuous. So limit x tends to pi by 2, f of x is equals f of pi by 2. So k by 2 equals to 3. So k equals to 6. That is how the answer for this question will come. These are really simple, not like 26th one. So here limit extends to 2. LHL 2 minus will be 4k, and limit extends to 2 plus RHL will be 3, and it is said it is continuous at 2. So LHL equal to RHL, so 4k equal to 3, k equal to 3 by 4. So that's how we do it. 28, 29, 27 are very simple. When it comes to 30 question, do LHL RHL for 2 and then do LHL RHL for 10. You get two linear equations, two simultaneous equations. Solve and find the value of A and B. Got it? So in my next video in continuity, I'm going to cover the remaining few sums that is left in the exercise and some very important questions from the rest of the books portions. Thank you.